In this video, I am going to find the derivative for y is equal to square root of x squared plus x using the chain rule for derivatives. Now, let's go ahead and remind you of the chain rule. Let's say you have two functions f and g, okay? And you compose these two functions to create a new function f composition g of x. Now, how do you find the derivative for this newly composed function? The rule is f prime of g of x times g prime of x. Now this is the standard format, but there is a more easier and convenient way of kind of expressing this rule. It's called Leibniz rule. Let's say you have a function y, okay, which is a composition of two functions f composed with g of x. Now, if you would like to find the derivative of y with respect to x, so that means finding the derivative of this function dy over dx, that is going to be the derivative of y, okay, derivative of y with respect to the function g, okay, and then times the derivative of g with respect to x. So this is just more common and more convenient way of writing the chain rule. However, let me go ahead and solve the problem here. So let's consider that I have two functions. Let's consider one of the function is g of x, and my g of x is nothing but x squared plus x. And then let's say I have another function f of x, which is going to be just square root of x. Now, what I'm going to do, I'm going to find the composition of these two functions, f composed with g of x, which is nothing but f of g of x. Now, let me go ahead and do a little bit of side thing for you here. How does function composition work? I'm going to create a diagram for you that will help you. So let's say you have this function g, you give it an input. Let's call this input x, and the output of this function is going to be nothing but g of x. It is very helpful to think of function as input-output combination. So you give the function g and input x, it gives you output g of x. Now what happens to this output is this. This output goes as input to the next function, which we call f. Now f is gonna take the input coming into it and give me f of the input. Now the input in this case happens to be g of x. And this is nothing but f composed with g of x. Now take this diagram or take this sequential concept, okay, of putting functions together and apply it to this composition right here. So f composed with g of x is f of g of x. So but my g of x is x squared plus x. So x squared plus x. And now what is my f of x gonna be? Now this is where many students or many learners go wrong. Think of f as taking an input, whatever the input value is, and giving you the square root of it. So let's say if you have f of m is going to be square root of m. If you have f of u is going to be square root of u. If you have f of u square plus v square, I'm just making something up here, is going to be nothing but square root of u square plus v square. And you should get the idea. Now in this case, by the way, f is taking as input x squared plus x, and all it is going to do, take the square root of what you gave it. And what did we give it as input? X squared plus x. By the way, this is nothing but this function y. So your y is this. Now we just kind of reorganize the function y as a composition of two functions, and now we are going to use the function composition rule, derivative rule for function composition, right? And find the derivative of this function. So that is pretty straightforward. Dy over dx is going to be the derivative of this guy d over dx, right? F composed with g of x, and that is gonna be f prime of g of x times g prime of x. At this point, you kind of have to simplify these two things. G prime of x is very easy. That's the derivative of x squared plus x. You know it's going to be derivative of x squared is 2x plus the derivative of x is 1. That's fine. However, this is the more interesting part. Here, you kind of have to treat f as if it's taking one input and as if that input is nothing but x. So my original f of x is square root of x, right? If I take the derivative of it, df over dx, which is f prime of x, right, is gonna be square root of x is the same as x to the power 1/2, right? So that's gonna give me 1/2 x to the power 1/2 minus 1. I'm using the power rule for derivative, right? So that gives me f prime of x is equal to 1/2 times x to the power negative 1/2. Now, instead of using this x, what I'm going to use f of x squared plus x and apply the power rule as if nothing has changed. Okay, the way I applied the power rule, I'm going to apply the power rule for x squared plus x, the way I applied it for just input x. So think of it as if nothing happened. So I still have the x. Kind of pretend that you are giving the function f a single input x, which you are giving a single input, right? But it's expressed in a format that's not very familiar to you probably. Now, having said that, what is it going to be? It's going to be square root of x squared plus x, which is nothing but x squared plus x to the power 1/2, right? Now, if I take the derivative of this, so I get f prime of x squared plus x. I'm taking derivative of f with respect to x squared plus x, like the way I have taken derivative of f with respect to x only right here, look, okay? And my input was x, and I'm taking derivative with respect to x. Now, my input here, by the way, is x squared plus x squared plus x, and I'm going to take the derivative with respect to x squared plus x, which is the same as taking derivative with respect to g of x, right? Or g right here. So that is going to give me 1/2. So 1/2 times x squared plus x to the power 1/2 minus 1, which, by the way, is the same as 1/2 times x squared plus x to the power negative 1/2. And I take this value and plug it in here. So it's going to be 1/2 times x squared plus x to the power negative 1/2. And that's how I find the derivative for the composition of two functions. I spent a lot more time on this problem because these are the fundamental and basic and simple ones. That's why I wanted to make sure that you are okay in understanding these steps, how it works step by step. But very soon you're going to look at this function, okay, and you're going to say, oh, the derivative is very simple. So I'm going to use the chain rule. Using the chain rule is going to be 1/2 x squared plus x to the power 1/2 minus 1 times the derivative of x squared plus x, which is just 2x plus 1. And there will be just a one-liner that will take you like 10 seconds. But I spent almost 10 minutes on this problem just to make sure that you are comfortable in understanding the basics, understanding the fundamentals. And then this is what you will do once you understand the basics and the fundamentals. Then afterwards, these problems are going to be natural to you, kind of like second nature to you, and you will automatically apply or subconsciously apply the chain rule to function composition without explicitly going through all these steps. I hope that this discussion was helpful. Thank you very much.